Hello everyone, we're going to go over the examples of the review for the test 2 that you're going to be able to find in my stat lab. So the first question is a theory question. What are some benefits of representing data sets using frequency distributions? That is the first part. And the correct answer is A, because what the benefits are is that when you organize data into frequency distributions, you are able to see any patterns and they become more evident by using the frequency distribution. Second question, what are some benefits of using graphs of frequency distributions? So the correct answer is B. It can be easier to identify patterns of a data set by looking at a graph of the frequency distribution. It's just also based on a picture can tell you a better story. So number 2, what is the difference between class limits and class boundaries? So I'll go directly to the correct answer is E. Class limits are the least and the greatest number that can belong to the class. Class boundaries are the numbers that separate classes without forming gaps between them. For integer data, the corresponding class limits and class boundaries, they differ by 0.5. And we're going to be working on an exercise where we will get to calculate the class limits and the class boundaries. Next, question 3. What is the difference between relative frequency and cumulative frequency? So the correct answer for number 3 is A. Relative frequency of a class is the percentage of the data that falls in that class, while the accumulated frequency of a class is the sum of the frequencies of the class and all previous classes. Question number 4. After constructing a relative frequency distribution, summarizing IQ scores of college students, what should be the sum of the relative frequencies? So I mentioned this a lot in class. So the sum of the relative frequencies is always 100%. If proportions are used, the sum will be 1. So it's either 1 or 100%. Question number 5. Determine whether the statement is true or false. If it is false, rewrite it as a true statement. In a frequency distribution, the class width is the distance between the lower and the upper limits of a class. So the answer is C. It is false. In a frequency distribution, the class width is the distance between the lower or upper limits of the keyword consecutive classes. Number 6. Determine whether the statement is true or false. If it is false, rewrite it as a true statement. So on number 6, the midpoint of a class is the sum of the lower and upper limits divided by 2. So this statement is true, so we don't have a need to rewrite it. Next question. We're going to be working on 9 questions in this video. So number 7, determine whether the statement is true or false. If it is false, rewrite it as a true statement. An ogive is a graph that displays relative frequencies. So the answer is C. The statement is false. An ogive, or ogive as I said in class, is a graph that displays the accumulated frequencies. Okay, so it's not the relative frequency, it's the accumulated frequency. Number 8, determine whether the statement is true or false. If it is false, rewrite it as a true statement. Class boundaries ensure that consecutive bars of a histogram touch. And that statement is true, so we don't have to rewrite it. Number 9, use the given minimum and maximum data entries and the number of classes to find the class width, the lower class limits and the upper class limits. So to find the class width, you're going to find the difference between the maximum data minus the minimum data, and then after that you're going to divide it by the number of classes. So this is going to be 61 minus 9 divided by 7. So this is going to give you a decimal, but if you look at the input box, it indicates that they want you to type a whole number. So here we always round up. So it needs to be rounded up. So when we enter this in the calculator, well, we have hired Diego to help us. We turn it on, and this is going to, let me clear, so it's going to be 61, I don't know why my lighting is so, 61 minus 9, and I like to press enter at that point. 61 minus 9 is 52. When we divide it by 7, notice that it's giving me the decimal 7.243. So this is a decimal 7.243. But in these exercises, you are asked to round up. Again, I wrote in here 7.43. So we round up, so this is going to become 8. Although normally that will not round up to an 8. It's just for class in this section, for this section. And then the lower class limits are, and it's good to read what is below the input box, especially now that your tests are going to be in my stat lab. So use a comma to separate answers as needed. So I'm going to show here the lower class limits. The lower class limits. And in here we're going to have the upper class limits. So the lower class limits, you're going to start with a minimum. It says use the minimum as the first lower class limit. It states it in there. So it's 9. And then to generate the other ones, we're going to use the class width of 8. So 9 plus 8, 17. 17 plus 8 will give you 26. And that's how we are going to generate, 17 plus 8 is not 26, it's 25. So this is going to be followed by 33, 41, 49, 57. The upper class limits, you're going to look at the second class limit, lower limit, and you're going to go one less. So 16 is one less than this second lower class limit. And then to generate the next one, you will be adding the class width of 8. So that will give you 24. That is going to be one less than 25 if you want to go that route. So plus 8. So this is going to be 32, followed by 40, 48, 56, 64. So they increase by 8, and they will be starting point will be one less than the second lower class limit. So we're going to stop here, and then when I'll be back, we're going to work on the rest of the questions. There are 9 more questions on this review.